Recording in progress.
Well, how you doing, Mike? This is Troy, and I know Angela is around somewhere.
Yep.
Earlier. Thank you.
Good. How are you?
Putting this presentation together to show us how to use the Funky Amp properly with the capacitor pack. And I guess I have some couple of questions.
Sure.
And I believe you're going to demonstrate the best way to utilize it.
Yeah, I can do that for you. I'd be happy to.
Very good. Thank you so much.
My pleasure. Just knocking out a little screen thing so I can see. There, I can see Troy. So, the Funky right now, I'm going to grab my phone for a second, Angela, and I'm going to play some more music so we can all hear it. And song quit. So, we've got music playing now. The song should start up. So this is a simple Funky like anyone would have with 3 inputs, and there's 1, 2. We're in input 1. And you play it like any integrated amplifier, it works just fine. I'm going to turn this and spin the stand for you. And on the back of this stand, I've got the connections for speakers and input, simple. And you'll see a blue PowerCon connector. Can you see that? Can you see the PowerCon? Okay. This is an FCF box. This is a double. This is FCF 2. We make FCF 1 and FCF 2. Each of them have over 300,000 extra microfarads, which is a lot of capacitance that support the transformer and the output. So typically, I made a little note, typically when you have an output IC or a transistor, as you raise the voltage for the transistor, you make more wattage. So a lot of companies will give you a wattage for a second. They'll turn these things up to high voltage, perhaps near 100 volts, to make that little output chip do 150 watts per channel. So in music, that would be very, very noisy. It's powerful. It sells a lot of amplifiers, but it's not great for music because as you raise voltage, it's like making the transformer louder, so it makes more noise. We run our voltages, this one in particular runs at, you'll see 31 volt down the bottom here. That means our noise floor is 2/3 quieter than most amplifiers in the industry at 60 volts or higher. So how do we get the energy if we can't just crank up the output transistor? Well, what they usually do is they put capacitors inside, right? And say typically 6,000 to 10,000 microfarads, little, looks like a C-cell battery inside. There's 2 of them. And those things will sustain music like water coming in from a small little kiddie pool that hit this cup of water coming down from the high voltage. So the higher the voltage you go, the more pressure they have dumping the water in. And then this little kiddie pool sustains our music when we run out, because this only lasts for a split second and depletes. So transformers can only do so much is what they're telling you. And it gives us a little bit of power. So what we want, when you're really a good designer and you do it by hand like in here, and there's no circuit boards and no slow down points, you want a lake of water, not a kiddie pool. So this is a lake. What's in this Funky to begin with is 180,000 microfarads. That's already a lake compared to the kiddie pools that the industry gives us. This is 680,000 more. And even in a regular one, I just don't have a 1 right now, which is 330,000. But this lake coming in on, when they're made by Gilbert Angela, are on 14-2 bars. You know that stuff that's in your wall, the 14-2 solid core wire? Well, there's 26 electrons per atom, so we've got a lot more copper. So our pipe coming in here is like a great big fire hose instead of a little garden hose. So our energy from the lake can help with the starting transformer energy very, very quickly. And because there's a soft start in here, right, this transformer is going to start up and it's going to see all this capacitance energy. And it's going to say, I have to charge you just like that. Gilbert has always put in a trickly soft start, which means he temporarily time delays the charging of these capacitors so we don't overstress the output, this transformer's output, so it gets hot and maybe melts or burns. And also the parts associated with supporting this charge up. It's going to click in right now. When I turn this, it's going to click and charge. Now the small light at the back here just lit up. You won't be able to see it because it's faint. And I said to Gilbert, well, why would you use such a faint light? Lights make noise. So it made sense to me to use it like that. But now it's glowing as the capacitors have all charged. And now we've added a lake to the sound quality. And truthfully, like a sock-eared fool can hear the difference between one and the other. So when I turn this up, I'll have more body. Things will last longer. More musically involving. It draws you into the music. It's not like listening to our standard stereos where we've turned them on and gone, that's okay for a couple hours, I'll go do something else. These are very involving, beautiful things. I think you've experienced that. So you mentioned bass and stuff on your amplifier. You had a great system with high power, and it sustained good energy and power, which is correct. And you were surprised that something at very low power, wattage-wise, could do anything that was similar to the good stereo that you had or the more expensive one that was big. And that makes sense because the industry has taught us that as there are all these shortcuts inside in capacitance or energy, we just want to have a lot of wattage. More wattage was the answer, but they're not telling you how much current is there. And current comes from the lake. Current comes from sustained energy because the wall can't replenish over and over. Your 120, 60 is our power. It's alternating. So it can't get back in here and keep filling it up. It's like our wall that has our electrical power can't charge quick enough. It's going out and back, alternating. And the transformer can't relay it fast enough. So we have to have these capacitors to give us constant energy to fill in the holes. And when you unplug it and plug it in, you can actually turn it on, listen to music, and then you can pull it out on the fly. Just like that. And get a before and after.
So can you pull out the capacitor pack, unplug it like you just did, while still connected to your source? Like
yes.
CD player?
Yeah, I've just done it here. My song on the streamer quit. I can start another one. I guess I should have put a few songs back to back together, but we can play another song for you. And I've got Jackson Browne playing here. So it's playing right now, and I'm going to go in. So I align my power con. I've made my upgrade to my power, and I'm listening to it. It's lit up. And I remove it. The capacitor inside still maintains, just not with the assistance of the lake. And here I notice subtle thinness that's there. It's still good because it's Gilbert's design and it has a lot in it to begin with. But when I put this in, the tone and body of the music changes and the background's quieter. It won't convey through a music, the music through a computer little pickup here. You won't hear that. But it's easy to hear standing between the two very good loudspeakers. I'm using some audio vectors that are worth about $6,000 a pair. And it absolutely is easy to hear. And we'll get you 600. But
capacitance or energy eventually drain with the capacitor pack being unplugged?
Yes, it will. So when you charge these, they take about 10 seconds or 20 seconds to charge up, and they really take about 10 or 15 minutes to settle. This amount of capacitors in a series array are like water, the ripples, they'll calm down in time in about 20-30 minutes, and they become very stable. And then when you're listening to them, it's just that little, it's like ballet, the little elegance, all the little finishes are very good. When you start the system up, it's not like it'll be bad for 20 minutes, it just continues to improve. And when you remove it, you're okay. The energy will stay here for as much as an hour or two. Once it charged up, because there's so much. I mean, you can imagine how many capacitors that are C-sized batteries that are in here. There's tons. And they're all linked on huge rods of copper, hand soldered, lead soldered correctly. And they all are floated in 40 durometer silicone, as are a lot of the components that Angela-Gilbert does, because vibration is one of the components of the moving target that is music. Music's moving, it's always vibrating, as is all of the gear. We all know people will take good stands and try to float the gear. You're just floating the metal. Angela floats the source of the parts themselves. The line stages, the output stages, absolutely everything. Transformers. All the vibrations are damped nicely, which again makes another difference. And it's in part of that funky you heard. So these little voltage, little wattage ones with all this energy sound like $10,000 amplifiers for very, very little money. And it's nice to have. We originally, the idea when I first went to Angela-Gilbert was to give something to beginners or people that are starting in audio, that so it wasn't $5,000. It was, I said, something for beginners they can latch onto, because thousands of dollars is a lot of money to people. And getting a good start and being exposed to something that sounds like $10 or $20 or $30,000 is very nice. And these funkies allow you to get an upgrade. So this will take you a long way in our line. That you can get up here. I've had guys with $30,000 and $40,000 systems of ours that are handmade, and they have a funky as a second system. And when they put an FCF and a funky together, they say to me, Mike, you know, if you told me I just had to listen to this funky, I'd be okay with that. And what they're telling me is it's getting the music right, just like our big systems are. Although it's not the finish of the finest that we make, it's so good, the enjoyment and happiness of the music, it gets the music right. And we're very proud of that. And we love that we can give people affordable stuff.
Is it possible, or can you leave it plugged in like a lot of solid state equipment? You can just, leave it plugged up and it won't be a problem.
Yep.
Would it be something similar with the funky amplifiers?
Absolutely correct. Yes, you can leave these plugged in all the time. In fact, there's no logic circuits in there, and leaving them plugged in, you'd have like brownouts or power fluctuations. That's why you'd worry about leaving something plugged in. And usually logic circuits, I see little chips, decision-making chips and things like that, they're more sensitive to those light microvoltage changes. There's none of that inside these. These are all point-to-point analog. So, and they're so ruggedly made, it's even more safe than any other component to leave on all the time. You'd be able to leave this on 24/7 and never have a problem with it. And as far as Gilbert stuff, and I haven't fixed anything from him since the beginning of the 90s. There's been no repair of any kind. So we'll hope that maintains. I'm sure it will, the way these things are made. They're not made like industry components. There are no circuit boards, there's no plugins. Those little arc points, the contact points of a pin letting loose and a collar point, all the little things that when you have 20 or 30 people in accounting and we're trying to make something in an industry type of production line, it's harder. You just can't do it. I mean, it's a lucky advantage that I found a wonderful artist that was chasing this hill without income for it. It wasn't done for money, it was done out of love. And the love of music and the love of achievement or going farther. Angela's like a 10-year-old that runs up the top of a mountain on a big achievement, goes like that for 3 seconds and goes, yeah, and where's the next hill? And I'd laugh. I'd sit there and go, oh my gosh, is this real? Are you really like an audio Nikola Tesla? All you want to do is burn components and go to the bleeding edge of everything? And it's yes, is the answer. I was looking, all the components, we're looking today at a industry component everybody knows. And some of the lines from the signal were passing through the amplifiers, they route them through. And we'd see little crimps of a pair of pliers or something turning in a line, and Gilbert's looking, I said, that's bad, correct? And Angela said, well, yeah, you're taking the edge of the wire, he says, and you're kinking it and moving it, and you're turning a hard 90, and you're also changing the diameter of the wire by compressing it. He said, and in a light, it doesn't matter because it's constant. And the ballast will find its way, and whatever residual noise or bad induction is, the light will work. But music's soft and subtle, and it's small little pieces, and it's moving. He said, so you want it to move evenly. Just bend the wire gently. Don't let it touch another wire. Don't crimp it, and have beautiful connections on the end, balls of solder joints full of metal. And then you vector or induct correctly. You get the music to flow because it's pulsing. And it just makes common sense. And you can hear each little thing, and it sums up that as you have these connectors or plug-ons, if those are bad singers in the choir, we all know one bad singer in the Vienna choir wrecks it. If one lady's got a cold, we can hear her. So when these are done more perfectly, it really helps. And that's why I think you've enjoyed hearing something that's so like an Einstein would say, is make something simpler, but not simple. In other words, achieve that task that you want, what's necessary, but use no more than is necessary and keep it simple so that you have the least amount of parts. Parts just do damage. They don't help. So that's the way we sum it up when you look at something like this. And then there's a lot of companies you'll see, too, Troy, that add capacitance. And because they're on circuit boards, and that's where I kind of would go over to the other computer and show you, if we've got a second I can do that. There's slowdown points. So they're not hearing what they've added. I could show you some of that too. Are we going to go over to the other computer?
Sure. We got about 9 minutes, so go
Okay.
ahead.
All right, we'll do. Sorry if that got too physics technical. We'll keep going. Thanks. I'm going to use this too. Okay. Whoa. I'm aligning my microphone. So. Got it. All right. So now we're unmuted over here. Can you hear me over here, Troy?
Yeah, I got you.
Good. Wonderful. Okay. So this is a power supply from a company that's made, and it has a transformer and 2 capacitors, as you can see. So because it was a dedicated type of connector to the components that were made by this company, you can't really do a lot with it. It has regulation for 24 volt regulators here. We just want 24 volt caps, and we want a 20 volt power supply. You only use this because you can't get this perfect. You regulate. When you regulate, you sit on things. But anyway, there's 10,000 microfarads. We added 30,000 more. And you can see how fast our water can come through on the bars. As you print it into this board you'll see there's tiny little copper traces that are 7/1000ths of an inch, and they're sitting inside here. This can't go very fast when you do that. It can go fast through that bar of copper. So we can only go so far. We added to it. It helps. But there are other limitations that are here. We don't have those on an FCF. So if engineering looked at this and they said, well, you know what, Mike, we're going to add 100,000 microfarads, which is 10 of these. The problem is they're not going to move the needle as far because they've limited its flow. And if so they're not going to hear it. So it doesn't occur to them that that's a reasonable expense or design. They'll say, boy, we got to do all this work, and our car's only going to go a little faster, so maybe we shouldn't do that. Well, when you do things correctly and you don't limit or regulate and you have flow of energy through bars completely, it gives you the needle of sound moving farther. But of course it wouldn't occur to an industry person to do that because they have to conform to paying a lot of wages and producing these things with more people. This is a Cambridge Audio amplifier that we modified. It has a nice toroidal transformer in it. Underneath here, you'll see 4 big giant capacitors, and then there's 14-2 rod and silicone that damps the capacitors. It's in a fly assembly. You can see the large conduits of copper that carry all the capacitance energy around. Underneath here, there's 2 of these that it started with. We've added 4 more. This modification moves the needle about 20 to 30% in sound in this thing, and it's $300 Canadian, which is not much of that's a whole lot of work. And it's because that we looked at what this transformer and rectifier bridge can handle in charging, and we figured how much energy can we give it. Yes, there's board mistakes in here that are going to slow it down, but at the same time, we think it's worthwhile. We've done it a lot. The people love it. There's been 10 or 15 people that have done this, and they all call me flipping out, which is great. And they usually get all their money and more for it because it's been Gilbert modified when they sell it, and ultimately they usually buy Funkies because they see that produced boards make mistakes and have thin stuff and slow down in too many parts, and they don't sound as good as direct point to point. You can imagine if I went to a line board that was, or line parts that were in the middle here, and I went for my volume control, which was physical, straight through, and I didn't have all of these logic circuits. That's not a volume control, you can see. It's just one of those spinners. That's a kinetic volume control. It uses tons of resistors. There's all kinds of parts in the front that show you the lights, what input you tapped. All these have logic circuits. They require decisions. Well, each of these buttons and decisions all touch the signal left and right. So how far? We can only go so far because you've touched it too many times. We can scope it out and you'll see the noise. So that's a wonderful mod. So that's an in-between. So we took mid-fi, and this started with 20,000 microfarads, is that right? And we took it to 60, which is more than a Yamaha that would have, 6,000 or 8,000 microfarads aside, or 12 to 18,000 total. So you keep going up. They're starting to admit that energy is important. Name Audio, for instance, admitted that they wanted 30,000 more in a flat cap, and we added to 60 because it's the max that it could take. And then for Angela-Gilbert Designs, it's this. This is one of our latest productions. It has not only a lot of caps, it's very heavy, Troy.
Wow.
Yeah. So this has 3 conduits in it. So this little section here is capacitors, very high voltage for a tube filament. So this does a tube stage for us. This integrated amp that's for it has a huge tube stage. You'll see all kinds of nice silicone to dampen any of this vibration. Huge bars of 14-2 rod and the most beautiful silver-looking solder connections you'll ever find. Another section, number 2 here, goes to the power amplifier. And there's another section that sustains the, what is it? Is it 2 point? How many million is this? Each piece?
Input stage?
Yeah, the input stage is
2.5.
2.5 million. So that's a big lake we're adding in the middle to support.
Yeah, yeah.
So actually it's over here, isn't it?
Both sides.
Both sides?
Outside.
Okay, so there and there is for input signal stage. Can you imagine? Most amplifiers have 2 of these and that's it. And we're doing 3 sections. 1 section for power, 1 section for line stage, so the signal, and 1 section for the tube filament, because we have an amplifier that uses tube and line together, and it's paralleled, and we can adjust how much tube and signal, and then we have a main gain. Quite an amplifier. But to show you this is about a 50-pound device. A soft start inside there, everything damp. This was plugged in about 2 hours ago. There's a light here. It still has full capacitance energy in it. It's lighting up the light. So that's much energy in this thing. I just tried it for the first time. We just developed this thing for a gentleman in Ottawa. And it was so night and day when I put it on. I have Gilbert's NSIG, which is the finest amplifier I've ever heard in my life. This went on a $15,000 amplifier. I don't know how much is this, about 5,000 or 6,000?
7.
This is a $7,000 advantage or upgrade. So let's say he's at 19.5. He now has in this $40,000 amplifier I had. This sounds like the $40,000 amplifier, and he didn't have to sell anything and lose any money, and he didn't have to upgrade and buy something new he's not familiar with. It's a bad business plan, but it's wonderful for customers. So that's energy.
That's amazing, Mike. Thank you so much. Appreciate it.
You're welcome, Troy.
30 seconds.
My pleasure.
So it's been a true blessing describing all the functionality and features of the Funky Amp.
Recording stopped.
Thank you.